Okay, this is Suhayab, Noman, Noman, Shuyat.
Yeah, I'm actually from another group.
Oh, okay. So who are in your group, Suhaya? Just two of you?
Yeah, we're just
Okay.
a group of two.
Okay. All right. All right. Go ahead.
Hello, I am Suhaib and my team member Newman.
Yeah.
We worked on sblob store, which is a distributed secure storage system.
Should I go first or not?
Yeah, go ahead.
Yeah. In the face of quantum computing, we all know. I mean, the news is very rife that quantum computing may render most of the cryptography useless. So we may have to find some other way to keep our data secure and keep the data communication between two users on the internet secure. So there are some major driving points of our project. So first of them is this the fact that quantum computing may render this cryptography useless. We targeted the file storage systems on the internet. So we just had a look at them, and there are some major breaking points of that design. So first of all, there's this there's this cryptography issue. The second thing is that there's a single point of failure, a single point of vulnerability. If we have a front end to our application and a back end to our application that stores all of our data on the cloud. So if we keep all of our data on a single if we keep all of our data on a single service, so there's a single point of vulnerability and a failure. The third point is that the providers cannot be trusted, especially if you are privacy if you're privacy sensitive. You may not be willing to trust the provider. And the fourth and the last point is that having a single service provider for your backend storage needs, it just gives them too much leverage over you. So some at some point they may deny to give you this service, and it just gives them too big a leverage. So will you please change the slide?
So one of the things that we noticed is that there's, according to the MIT Technology Review, there's a harvest now and decrypt later ideology with some hackers. So they're trying to harvest the data today to decrypt it tomorrow using quantum computing. So our approach is to actually shred the files. So it makes it harder for us, for hackers to harvest the data. So what we do is we take a file and we shred it across multiple providers. The goal is to provide an application that minimizes the amount of changes that needs to be done to the application. And we want to minimize also overhead. So we use streaming, byte streaming, instead of downloading the whole file and then sharding it. We actually shard on a stream. And we also include a redundancy replication so that we don't depend on one provider. We can survive a single provider failing or going offline. Our service runs on either the client or a server. And it's just really, all you have to do is reroute your endpoint to our service. And we use S3 because it's like the lingua franca of all data store. So I'm going to go ahead and provide you with the demo. So here's our service. And we're going to run up three S3 simulators. So the first thing we're going to do is we're going to try to get a file that does not exist. As you can see, it's not found. And then we're going to go ahead and write a file and read it again. And as you can see, the file's now available.
Mm-hmm.
And the contents of the file, as you can see, is sharded on a byte level. So you can't really fully have the data unless you have all the parts. And we also have our redundancy bits, which allow us to survive a single failure. So let's go ahead and simulate a failure. So I'm going to take down server 2. And we're going to go ahead and read the file again. As you can see, we can actually read the data in the file. And what we're going to do is we're also going to test redundancy on writes. So we're going to add content. So it's alerting us that one of the servers are down, but the write still went through. And if we go ahead and bring the server back up, our write remains consistent. So that's the end of our demo. So what we have implemented is redundant sharding and joining on byte streams. So this is a library that could be used with other methods. It's not really restricted to our current application. It's a generic library. So far, what we have implemented as far as the S3 API is the get, put, and delete, which are the core foundations of file storage. We are also resilient against single provider failure, both reads and writes. That's pretty unique because a lot of services that are resilient are not resilient against writes. And yeah, so for our future work, we would like to fully flesh out the S3 object and bucket APIs. And then another thing that we would like to tackle is healing on failure. So right now we are resilient against failure, but we don't really heal. And there's an opportunity to heal the data to make sure that future reads and writes are consistent.
I guess
then-
I guess that was my question when you brought down one of your server, right? And you can still write it. And how will that copy and when will that copy, when they back up, they will be able to in sync with others?
So we currently do not resync it.
Okay.
But in the future, when we read, we want to like recognize, because we currently detect that there's a faulty copy, right? And in the future, we want to heal that by using the other replicas, schedule a healing process. Another thing is because we're injecting into the process, we can actually provide transparent encryption of sharded data. Other opportunities, we noticed that probably copying bytes on a stream is actually inefficient. So we would like to provide a sharded buffer library so that when the user writes to the buffer, we're actually sharding on the write. So we don't have to do many clones. So it would reduce the amount of copies we do. Of course, there's benchmarks that need to be done. And we also would like to consider other storage backings because S3, even though it's like very readily available, it's somewhat restrictive for extensibility. So that's all we have, and we're open for questions.
Okay, so that's good. Your motivation and your presentation as well as your demo is very clear about what you're doing. That's good, and thank you for your effort and putting things together. So I'm actually going to make some. I don't know whether that's you can think of that as a suggestion or something which is may not be needed to implement. So I'm thinking about your motivation of try to deal with the future technology such as quantum computing. People, as you said, people trying to harvest all the data and decrypt it later. So that has been there. I have been thinking, yes, you have, even if you have the most powerful tool, when you try to decrypt, you have to have some way to know your decryption is correct. Your decryption is correct in the sense that there is some sort of a way for you to actually check that this is a meaningful data. Okay, that's basically when you want to do cryptanalysis. That's kind of, you assume you'll be able to know when you're done or which algorithm you need to use that. So I'm actually thinking about your storage, about the concept blending. So the blending means that you have your data, I have my data. We both want to store in your system like S3, but in the chunk, our block are actually blended together. When our block are blended together, either of us can actually decrypt. But when we decrypt, we only decrypt it's blending part. So it's only decrypt the part that's actually belong to you. So you won't be able to decrypt the other person. So when you see your block, is going to be some block that's going to be meaningful, but there is a garbage in the middle here and there. and we need a method for the client because you actually provide you're involved in the blending process. So you actually have a way to know how to tell whether the bytes, which bytes are belong to you, which bytes belong to the other. So I don't know whether we have a crypto tool for us to do this kind of blending, such that I'm actually thinking about blended, then doing this kind of double encryption, not encrypted, then blending. That is a little bit different. I think I don't have a tool to do this kind of, to actually have this kind of dual encryption or dual decryption that you only decrypt certain part. And I don't know how to do that. And in my mind, I'm thinking, if you do this, if you harvest the data, you can still break it. You can still try to separate, but this actually going to be another level of complication about how you can actually find out. Because if I look at the data, I realize that, oh, this part is actually random, but the other part is actually makes sense. So how do you actually be able to make sure you're doing the right thing for crypto analysis? Obviously, I'm not going to tell anybody about the checksum about the original content, and so it might be interesting about how we can use this kind of system, and then the data can be blended in an arbitrary way. I'm talking about just 2 user. We could blend it with 6 user or 100 user. Of course, the network bandwidth, the storage is going to be more expensive because I only have a little bit. But on the other hand, my robustness is actually higher. Robustness higher means that I will be able to get multiple copy from everywhere. So that's just a suggestion. If this kind of system, we might need this kind of new crypto to do that. I might call it dual decryption, dual encryption.
Yeah, it's definitely a good idea, I think, because like our platform actually could be extended to support something like that in an abstracted way. And I think the best part of this is that the user doesn't have to know what's happening behind the scenes. They kind of could just run our process, and then we can do all that in the background. But it would be interesting to try to figure out how do you do that. Like when you're trying to like accept 2 network connections, you can probably queue them together to merge them. But our goal is to try to be as consistent with S3's API, which I think is really cool, like that we can integrate these things behind the scenes without the user's involvement.
Right. No, I think that this is definitely needed, this type of capability. It just, I do worry that there are some big provider, they have some of their capability, like AWS. I mean, they potentially can actually do something very similar to what you're doing. And for them, it's actually fairly easily. Of course, they can actually open the API, so you can actually work with other cloud provider. I'm just thinking, maybe you can actually add a little bit, some extra new way of looking at the information to be then head to head in this process. Obviously, what you're thinking, it looks to me is a heading to a star company. I mean, I'm sorry, I'm pulling out my entrepreneur due diligence hat, is that the obvious question we'll ask is that what's your market advantage over those? Yeah, even though
I think it's if I don't know, I'm just gonna try to like thinking about it on the spot. I think that the biggest advantage here is that it's distributed through multiple providers, right? So like even if AWS comes into the market and provides a solution, it's going to be AWS specific, which means that if AWS was to be hacked, theoretically, that vulnerability will leak all the data. In this case, you need AWS to be hacked, Google Cloud to be hacked, and Azure to be hacked. So you can get all the pieces together to start forming the data. And then you have to figure out how to map these data components with each other. But like, as you said, like if we can do some more blending in the process and encryption, we can actually increase our level of security even beyond what they could provide.
Right. Okay, all right. Okay, I finally realized how to pronounce your name correctly. It's a Suhei,
Awesome.
right? Yeah,
Yeah.
I don't know how to figure out the YAB at the end. How do I
Yeah,
actually
it's
pronounce that?
it's kind of confusing. Yeah, but you
Yeah,
got it right.
yeah,
Yeah,
Suhei.
perfect.
Now I know
Yep.
Suhei. Yeah. All right, thank you. Any other question or comments?
Not really. We do have a spare slide that explains the consistency model, but
Okay, sure. You want
other
to
than
show
that,
me that?
yeah, it's we're using commit IDs basically. So like every time data is coming in, we use a commit ID. And then if this one fails, for example, it's going to have the old commit ID. So we do like a vote. And then if the majority wins, of course, and we would start reading from these two and exclude this one.
Okay, so it's a majority vote kind of idea.
Yeah.
Okay. Okay, good. All right. So let me ask the other group. Shuyan, are you is your group also have the same slot or different slot?
Yeah, I'm also 10 o'clock.
Okay, do you have a partner or just yourself?
No, it's just myself.
Okay, okay. Why don't you go ahead?
Okay. So actually, to share my screen. So today I'm going to talk about remote OS, and it's the concept that I've been working on for a while. And it's really a OS level interpersonal networking concept. So let's go. And so we've been living in this pandemic for a while, and it really proved that it is possible to work large scale in a remote environment. A lot of people used to think it's impossible. Now that we are forced to do this, we kind of realize that it's actually doable. So there are a lot of benefits of working remotely. You have reduced expenses. You're more environmentally friendly. And I think most importantly, you get to spend more time with your family. And I guess that's really a good pro of remote working. And however, there are some problems with remote working. So the first big one is that a lot of employees don't feel like they're at their best when they're working from home, because they feel like they're not in that workplace environment. So they're just feeling like they're staying at home, maybe on a vacation or something. They don't feel like they're actually working. And there's also a lack of effective supervising. So usually the boss is really nearby the subordinates, and it's really difficult to really check on the employees when we're doing work remotely. And finally, there's the missing of in-person communication. And a lot of people really like that instead of doing emails or video calls. So we should try to find ways to fix those. So here are some issues when I was working on this project. So the first one is that there are a lot of existing apps that already do what I want to do. So why are they not good enough? And I think the first reason is that the integration is very bad, because all of those apps, they're not done at a OS level. So it's really confusing, and they can't really talk to each other. So they can't provide a consistent experience. And the second point, which is really what my demo would be about, is workplace simulation. So you don't feel like you're working in a group. You feel like you're working on your own, because you can't see what other people are doing. And finally, they're not privacy aware. So they don't really care about whether you're how much privacy exposure you would like to experience. And I think that is another important point that a lot of people are kind of ignoring. So let's talk a little bit about workplace ethics. So first point is that I don't think we should monitor the employees, even though they're working for the company. I still don't think it's ethical to just fully monitoring them, because people don't like being watched, and I think it's actually bad for efficiency. And also constant disturbance is bad, so we don't want too much we don't want too much kind of disturbance between colleagues. So like we don't want to make it too easy to for them to kind of check on each other. So it's just, we want that real life workplace experience. So we still need to have some supervising though, to make sure we have enough productivity. So what exactly is missing in the OS? I think that thing is workplace dynamics simulation. So it's really, we need to separate our working life and just living life. So a lot of people do their work on the same machine as their as their personal machine, and they don't separate their files, their personal files and professional files. And I think it's really because the operating system doesn't make it very easy for them to do that. And I think it could be very convenient if the operating system has a feature to do that, to do these things. So we have check on what colleagues are doing, and video call integration. By that I mean video calls with a better quality, like at least FaceTime quality, not Zoom quality. And also we want strong do not disturb functionality, so we can know that when someone don't like to be disturbed. So this is a little bit about separating the space. So it's kind of like virtual memory in the OS. So we don't want an app to access the memory of another app. And I think we should also do that when it comes to work. So it's actually, I think it's very helpful to prevent security breaches. So I know there are a lot of cases where people just accidentally send their work file or their sensitive file to another person, which who are not supposed to get a file. And I think this practice will likely avoid that. So it's kind of, so here is a structure that I designed. So for each member of your team, you have like your status and what app you're using, and where are you on do not disturb or not, and are you open to call. So in a complete implementation of my concept, it would be contain all these features at least. So it will make it very easy to call or text someone, but we will also know if they would like to be called or be disturbed. So I think that's really important for work. So there are some apps that already do this. So for example, the Steam app. So you can, the Steam app is the game community, and it can show all of your, what all of your friends are doing, what games they're playing, are they online or offline. And also there's the Apple Screen Time. So on Apple Screen Time, it can show what apps you're using and how long you've been using them. So it is kind of a proof that we can actually get this information, and it's already been done. And we can share this information to other colleagues if we want to. So it will create a sense of workplace dynamics. It's just like walking past your colleague in a real office. And also there's on Apple iMessage, it has this notification silenced this line. It shows that your friend doesn't want to be disturbed, so that you will know that they're really doing their work and you shouldn't really call them. So this is just a proof that all of those features are kind of already implemented, but not in an integrated way. So it's really, but on the other hand, it's really difficult for me, for myself to do all those features. So in my demo, I would just show a little bit of what I've been working on. So it's really more about the showing what others are doing part. So here is here's my demo. So here we are using JSON RPC in C++, so that the same framework. So we have a server and 2 clients. So here let's open up the server. So here is a server, and here are 2 clients. So we have client 1 and client 2. So here we're simulating that we have 2 workers working on the team. So the server is the team server, or it could be the company server, depending on how it is implemented. And here we have different status updates. So here we don't have automatic status update. So we're kind of having, we have to do it manually. But so here, if we type W, it's kind of similar on Linux. So here it will return a JSON with all the users. So we have system status and user 1 name. So it's inactive because although it's active, it's not updated. So it's user 2 and user 3. So all of them are still inactive. So here we can change our state to active. So here's my command. So I can change user 1 to active. So here it says that it's already been changed. And now if we look again, here it's the user 1 has been changed to active. So now if another colleague logs in, like for example, if user 2 logs in, and you can see that, oh, user 1 is active. So I can probably speak to that user or call that user. So we can also do like a name change here. So if we do this and we type rename user 2, for example, to Bob. And now if we go back to user 1 and we do this again, we can see that user 2 has become Bob. And now Bob can be active. So if we check again, then we can see that Bob is now active. So this is a very kind of rudimentary implementation, and it's definitely just a very little part of what I want to achieve in my concept, but I think it's a good demonstration of how this is very doable, but it's just not really implemented very well in modern operating systems. Yeah, I think that concludes my presentation.
Okay. So Shuyan, I think you got some really great idea here. Let me tell you what I think. I have been thinking since you post your slide very early. You say, why should we implement this in the operating system?
Mm-hmm.
Because each of the application they already develop, some functionality looks like this. Some, for example, Sting, you mentioned Sting is actually doing some of that. And in some sense, Facebook or the social media, they actually provide some information about this user is online, whether this user is active.
Yeah.
It's just they design for that particular application.
Yeah.
So let me actually tell you the scenario I'm thinking. So you now have a name and whether you're active, right?
Mhm.
But the other thing which I think is important is just tell people, hey, anybody is actually on the other app. Say anybody on Discord. I want to go to Discord, this group. So you can see that a lot of us when we communicating, for example, when you play a online game,
Mhm.
and it's a team game. So you're actually playing this game, play in the middle, say, hey, let's get on to Discord. And the thing is that is between the game and the Discord, they actually have some sort of communication and such that people manually go there and go over there to do
Mhm.
that. So I'm actually thinking what you're doing, you might not need to do that within the operating system kernel, but you definitely can do it in a way to support multiple application for this kind of communication.
Yeah,
But,
it's probably it can also be a framework of some sort.
right, your name and the status, basically that's going to be telling other people whether you're online as a person.
Mhm.
But I think it's missing right now, based on your implementation, is that you can actually communicate, I want people to go to this application, and I want people to look at this particular chat within this application.
Yeah, that's a
So
good idea.
that will help people. So the thing, let me tell you that this will help me personally greatly, because today our communication become, oh, what should I do? I check my email. Did you send it to my email? Did you send it to Canvas? Did you send it to
Yeah.
Discord? Did you send it to Facebook? So I have, I mean, for me, I have even multiple Facebook accounts. So the thing is that I have to actually log in 5 or 10 different places to see if I have any activity. But having something like what you provide is actually helping me just check this place. And then I know which application I have activity I need to deal with. And this is a little bit different because it's actually going to be real time, meaning that if I want to do something next half an hour, then this application will help me. Where should I look for information? Where should I communicate with other people for that half an hour activity? Because there's one single place for you to look at this. And today, a lot of new application from the user perspective is I'm actually using multiple applications at the same time, not just using one application. For example, we're using Google Doc to do a presentation,
Mhm.
and somebody actually makes some modification, and then but I'm in the other application, so I need to switch back to take a look at that. So this kind of smooth transition is actually fairly inconvenient today. And once you be able to notify, you might be able to integrate it into operating system and such that those applications will be invoked automatically. So for
Mhm.
example, somebody asks you to look at Discord, but you're not even not you're not logged into Discord at this moment. If you want to do that, you have to actually click and then go in there. But you can actually configure. So next half an hour, these 3 people, if they want me to get into anything, the operating system will automatically pop up that window. I think that capability for a half an hour meeting will be the most efficient. So you can think about right now we're doing implementation, and there might be some kind of remote virtual terminal that you want to pop out on my screen so I can actually see that. So this kind of coordination, I think, is very essential, which is it's probably the operating system if we want to like share some virtual desktop or something like that. The other issue, which is I think is related for what you're doing, think about this example that your final project is only work by yourself. So that's unfortunately, this is not going to be the case. But most of other team, they have a 3 or 4 student. So when they are working on the project, it's typically one person is working on the project, and then you have to check into the GitHub, and the other person will actually be able to look at it. So the software development environment that today people have is that, okay, I actually check in, and then you either concurrently modify the file and you also check in, and we try to do all kind of concurrency control to make sure that we don't conflict with each other. Or you have to actually ask me saying that, hey, I'm done. Now it's your pass. So why don't you take a look at that? So that actually hasn't been kind of ad hoc, and it's not transitioned very smoothly. So for example, your platform potentially can do that as well. So for example, I said we are working together for half an hour, like a workspace. So this half an hour, we actually allow this kind of transition very seamlessly. Like your code, after you're done with this, you click a button, immediately it push. So this become my responsibility on my window. Now I can actually start doing that. So the workflow become much more integrated into the whole thing among different applications. So I think that we have probably, as you said, we have probably individual application to do part of this, but I think it's a good idea to have an integrated service into this.
Yeah, that's one of the reasons why I think it would be, or it might be a good level, a good idea to do it on the OS level, because it's really easy to integrate everything, all of the features into the system, and the system has the ultimate power to just have all the information available, and it can control what windows you're opening and what conversations you're having. So it's like the big brother. So it knows everything.
Well,
and
the reason I say it's not going to
Yeah.
operating system kernel is that I
Mhm.
believe to do this effectively, this has to be a distributed operating system,
Oh yeah, that's
because
true.
one
Yeah.
kernel can only control one user, right?
Mhm.
And you want to really simultaneously coordinate a large number of device, maybe among 5 user, and then with both our laptop, desktop, and our phone together. So you can see that is actually require a lot of distributed coordination. I think that eventually they need to authorize to get the privilege of operating system kernel, but the distributed system part is how do we coordinate, whether you have a one service provider or you want to do peer-to-peer. That's actually in the air about how you want to do it. Yeah. Okay, good. I'm glad that you actually work it out this quarter. I know at the beginning of the quarter, you actually mentioned some idea to me, but it was very vague at that time.
Yeah.
I know you're heading a good direction, but I don't know. But then now I know a lot better about what you're doing.
Okay.
I think it makes sense. Yeah, I encourage you to continue to work on this area. Okay. 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 Is there another group in this slot? I guess not.
Yeah. So
Okay,
are we doing our homework demo here?
Let me stop